Dear students, let us begin the third part of the lesson, in which you will be learning about the test statistic for difference between two means by describing mean difference and standard error of the mean difference. We can define mean difference. The mean difference represents the difference between the sample means of the two groups being compared. It is calculated by subtracting the mean of one group from the mean of the other group. The mean difference provides an estimate of the average difference in the outcome variable between the two groups. We can calculate the mean difference. First, calculate the mean difference of each sample. Let us denote them as a x1 bar and x2 bar for the sample means of sample 1 and sample 2 respectively. Then compute the mean difference. It is noted as a d by subtracting x2 bar from x1 bar. That is, mean difference d is equal to mean 1 minus mean 2. It is nothing but d equal to x1 bar minus x2 bar. The mean difference represents the observed difference between the sample means. We can define standard error of mean differences. The standard error of the mean differences measures the variability or uncertainty associated with the mean difference. It takes into account the sample sizes, sample variances and the correlation, if it is applicable, between the two groups being compared. The formula for calculating the standard error of the mean differences depends on whether the samples are independent or dependent. Independent samples. If the two samples are independent, the standard error of the mean differences is calculated using the following formula. That is, standard error is equal to square root of s1 square by n1 plus s2 square by n2, where s1 and s2 are the sample standard deviations of the two groups and n1 and n2 are the respective sample sizes. Next, we can define paired or matched samples for the dependent samples. If the two samples are dependent, meaning they come from the same individuals or entities, for example before and after measurements, the standard error of the mean differences is calculated using the following formula. Standard error is equal to sk by square root of n, here where sk is the sample standard deviation of the paired differences and n is the sample size. Test statistics. The test statistic for comparing the means of two groups is typically calculated by dividing the mean difference by the standard error of the mean differences. It helps determine the likelihood of observing the obtained mean difference under the null hypothesis. For example, we consider the test statistics t can be calculated as follows. Therefore, t is equal to x1 bar minus x2 bar divided by standard error. Here x1 bar and x2 bar are the sample means of the two groups and SE is the standard error of the mean differences. A company wants to compare the effectiveness of two different advertising strategies on sales. They randomly select two groups of customers. Group A is exposed to strategy 1 and group B is exposed to strategy 2. The company collects sales data from both groups and wants to test if there is a significant difference in the mean sales between the two strategies. Group A strategy 1. We are having the informations sample size n1 is equal to 30, x1 bar is equal to 500 and sample standard deviation s1 is 50. For strategy 2 for group B, the sample informations are sample size n2 is 25, sample mean x2 bar is 480 and sample standard deviation s2 is equal to 60. So, based on the above information, to calculate the test statistic, we need to determine the mean difference and the standard error of the mean differences. Therefore, mean difference is equal to x1 bar minus x2 bar, it is nothing but 20. Standard error of the mean differences. Since the samples are independent, we can calculate the standard error using the following formula, that is already stated. Standard error is equal to square root of s1 square by n1 plus s2 square by n2. Here we are substituting all the values in this formula, we got 15.07. The test statistic is calculated by dividing the mean difference by the standard error, that is t equal to x1 bar minus x2 bar divided by standard error. It is approximately equal to 1.33. In this example, the test statistics is approximately equal to 1.33. This test statistic will be compared to critical values from the t distribution, or a p value will be calculated. To determine the statistical significance of the difference between the mean sales of the two advertising strategies. Dear students, let us summarize what we have learned in this lesson. We have discussed in detail about the null hypothesis and alternative hypothesis with suitable examples, and random sampling distribution from normal parent population, and we have also discussed about test statistics for difference between two means by describing mean difference and standard error of mean difference. Dear students, I hope you understood all the concepts, and also these concepts will be very helpful to you in your research. We have completed our lesson on the null hypothesis and alternative hypothesis, the random sampling distribution of difference between two sample means. Thank you.